So good evening guys. So in last class we completed about units and dimensions and measurements and errors. Okay. So the first thing we completed basic math. Second one is measurements and errors. And the third one is units and dimensions, right? These are the things we completed. So in the next class, in the next upcoming session, we'll go with kinematics. Okay. Yeah. So the next topic is kinematics. So in kinematics, we will mainly focus on the motion in a straight line and motion in a plane. Okay. So first thing, introduction of mechanics and kinematics. So mechanics is nothing but it's a branch of physics dealing with motion of a particle and bodies and force acting on them. Okay. Whereas kinematics describe motion without considering the cause. So this is the main thing we are going to focus now. Okay. So like if I talk about a body having a velocity or acceleration, we won't talk about how the body is getting velocity, how the body is getting acceleration. We are only focusing on it's going with some velocity or going with some acceleration. Okay. That's the thing of kinematics. Okay. So in kinematics, we divide that into two parts. One is straight line and one is plane. Okay. So motion in straight line and then plane. When we talk about a straight line, it is a one dimensional thing. Either it can be x axis, y axis or z axis, anything. But when we talk about a plane, it is having two axes. One is x, y or y z or z x. Okay. That is the main thing of straight line and plane. Okay. Next thing is dynamics. Studies of motion with respect to the causes, like how the velocity or acceleration has been taken place, like by applying how much force it has been taken place. Okay. That is the dynamic we will say. Next is motion is always measured with respect to relative to the reference frame. If I take a object or a point, so for example, if I take a point A and point B and point C is there. Okay. Point C is there. Point A is moving with, changes its position with respect to time I will take. Okay. Changes its position. Suppose this is the initial position and final position is this one, A initial and A final. Okay. A final. According to C and B, A is in motion, right? No, because it changes its position. When object changes its position, we say it's having displacement. Displacement is nothing but it is going with some motion, right? Yes. So when I when I take a B and C, with respect to C, B is in rest because there is no change in position, right? No, there is no motion, right? No. Yes or no? Yeah. When object is having or object changes its position with respect to time or changes its position, we will say it is in motion. Okay. Whenever we talk about a motion or rest, we will take a reference frame. Okay. Reference frame. Yeah. So few general points of motion. So velocity direction is nothing but motion's direction. When object is going in x direction, like velocity also will be in the same direction, no? Yes or no? And acceleration may or may not be in the same direction. Why acceleration is not same? Because if I apply some acceleration, like you are going in bike, you are applying some acceleration, you will move forward, right? No? Right. But one more thing, like friction is there, no? Friction is applying in opposite direction, which means I am going forward, but it's opposing in me Yeah, opposing force is there. So it is in the backward direction, or I mean opposite direction, no? So acceleration may or may not be in the same direction, but velocity is the direction motion. Okay. Straight line is nothing but one dimension, will say curved path, like curvilinear will say, right? No, it's a two dimensional, will say, like circular motion or projectile motion. Okay. Circular motion means any example? A wheel we can take, no? Wheel of a vehicle, or when we go for which one? Watch, clock. Yeah. So examples we can say circular motion and the one dimensional motion. Okay. So this is two dimensional, will say, and this is one dimensional. Next is like a straight line motion is nothing but a one dimensional motion. Curved path or curvilinear motion is said to be a two dimensional motion. Okay. On a curvilinear path, velocity is tangent to the path. When I talk about here, when I talk about the velocity here, no, it is in the same direction. If I want to find what is the velocity direction in this curvilinear path, simply take a tangent over here. If I want to find at this point, no, take a tangent like this. Okay, take a tangent. So this is my velocity direction. If I want to find here, take a tangent over here. So this is my velocity direction, right? No. So when I talk about a circle, at this point velocity will be in this direction, no, tangent. At this point, if I want to draw a tangent, this is my velocity. At this point, yes, no, I can draw like this, and I can say that this is the direction of my velocity, right? No, is there any doubt in this? To find the direction of the velocity of given graph? No, right? Yeah. So acceleration depends upon the net force. So when we come to the circular motion, no, we will talk about the acceleration thing. Okay. And if velocity and acceleration angle theta is less than, 0 and less than 90 and greater than 0, speed increases, and greater than 90 and less than 180, speed decreases. So it is simple thing. When I take a graph, no, like this. So this is my graph, simply I will take, this is my graph. If I want to find whether speed is increasing or decreasing at point A, and this is point B. Okay, let me take, this is point A and this is point B. What is the main thing? Theta greater than 0, less than 90, speed increases, which means this angle is acute angle, no? Acute angle. And this one is obtuse angle, no? Obtuse angle. So take a tangent here. Tangent. So draw the angle with respect to horizontal, that is x axis. Is this angle is less than 90 or greater than 90? Less than 90, no? So which is speed increases. Yes, no, speed increases. Suppose I am getting greater than 90, like angle will be looking like this. Yes, no? It means speed decreases. Okay, that's the main thing. So example here, like velocity of a particle at some instant is v, find the speed of a particle at this instant. So whenever you are getting the velocity like this, no, okay, we will go into the topics like distance, displacement, velocity, speed, everything. But before that, like examples are there. Okay, like v is equals to 3i cap plus 4j cap plus 5k cap, which is the velocity. If they are asking speed, no, take modulus of that. Okay, modulus in the sense v will be equals to, like v modulus will be equals to under root of 3 square plus 4 square plus 5 square. I will get the speed. Okay, take the modulus of the velocity, I will get the speed. And example 2, listen carefully. A lift is ascending. Ascending means going up, no? Ascending, going up, descending, coming down, right? No, with decreasing speed. Okay, the thing is, there is a lift going upward. Going upward means velocity towards up, no? That's the direction of the velocity. If I am going up, velocity also will be towards up. So this is my velocity. And decreasing speed. Decreasing speed in the sense, what are the directions of velocity and acceleration of the lift? Decreasing speed. So I am jumping now. Okay. So some velocity I am going. I am to the height h. Okay. Now again I am jumping, but I am going up to height h by 2, half of the height. So someone is pushing me, no? Someone is pushing me. So which direction acceleration acting? Downwards. But velocity is acting upward. So can I say like velocity direction is upward, but acceleration direction is downwards, right? Now ascending with decreasing speed. One more example I will give. Lift is ascending with increasing speed. So what is the acceleration direction and velocity direction? Both are same. Both are in the upward direction, right? Now, so lift is descending with increasing speed means both are same direction. Think. Lift is descending, going downwards with increasing speed. So obviously velocity also in the downward direction, acceleration also will be in downward direction, right? Now, yeah. So now the classification of motion. So as of now we have talked about one dimensional, two dimensional, the same thing. So first way, one dimensional motion along a straight line. Second is two dimensional motion in a plane. Okay. Third is 3D, which is motion in a space we say. Okay. First one, 1D nothing but straight line, two dimensional is nothing but it's a plane we'll talk, and three dimensional is nothing but space, x, y, z, everything we'll talk. Okay. So second way, uniform motion. So uniform motion in the sense going with same speed, no, same velocity, same speed. In that case, acceleration is there? No, right? Now, no acceleration. It's a constant. Velocity means acceleration will be 0. Constant velocity, acceleration 0. Second is uniformly accelerated motion. Uniformly accelerated motion in the sense at time t1, I will write here. At time t1 is equals to 0, velocity is, or t1 is equals to 0, I mean t1 is equals to 1, velocity will be equals to 5 meter per second. Okay. Then at time t2 is equals to 2, velocity is 6 meter per second. At time t3 is equals to 3, velocity is 7 meter per second. Here speed is increasing, no, or velocity is increasing, no. How the velocity is increasing? Constantly it is increasing, which means acceleration also increasing constantly, no. 1 meter per second square, 1 meter per second square, 1 meter per second square. So for each second, acceleration also increasing constantly, right? Na? Yeah. So uniformly accelerated motion, constant acceleration. So non-uniformly accelerated motion means variable acceleration. So here, how can I take the example? At time t1, velocity is 5 meter per second, but at time t2, velocity is 7 meter per second, and time t3 velocity is 15 meter per second. Here acceleration if I see, it is 2 meter per second square increased. Here it has been increased more. It is not constant, right? So it is non-uniformly accelerated, we'll say. Okay. So note equation of motion like v is equals to, like kinematic equation we have seen, no. So those kinematic equations are applicable for uniform acceleration. Okay. So this is applicable for uniform acceleration. We have seen the equations, v is equals to u plus at, v square minus u square equals to 2as, s is equals to ut plus of at square. Okay. These equations are applicable for the uniform acceleration. Okay. Yeah. So in uniform motion, velocity of a particle is constant, which is acceleration is 0. This is the first point. Velocity is constant, its magnitude is constant, which means direction of velocity is fixed. Okay. If you want, you can take this. Then no. Now the basic definitions. Okay, suppose if I take a point, no, this is my point P. Okay, this is my point P. So the point P is nothing but x comma y comma z. I'll take. Okay, x comma y comma z, and okay, here we have taken point A and point B. Okay, let me consider this is point A only, and point B is this x1 comma y1 comma z1. Okay, so origin, what is the point of origin? 0 comma 0 comma 0. Okay, 0 comma 0 comma 0. So this is first position of a particle and this is second position of a particle. Okay, position how we will define is with respect, like will like define as r. Okay, small r will define, and displacement is nothing but change in position, will say, no. So if I talk about the position r1, which is nothing but OA, r2 is nothing but OB. With respect to origin, we will take the position of a particle. Okay, here x1 I cap plus x2 y1 j cap plus z1 k cap. I j k is denoted for x axis, y axis and z axis. Okay, and y x2 y2 z2. Okay, here we have taken this is x y z, x1 y1 z1. Okay, these are my positions. When I talk about displacement, displacement is nothing but change in position, no. So how we will take the change in position? Final position minus initial position, right now. So displacement vector denoted by the letter S. So displacement is AB, which is nothing but OB minus OA. So what is OB? The final position. OA is initial position. When I take x2 minus x1, y2 minus y1 and z2 minus z1 will give the displacement of a particle. Okay, so one is position, second one is displacement. So position vector gives the exact position of the object, displacement vector will give the change in position of the object. Okay, done. Okay, so the difference between distance and displacement. Okay, so when we talk about distance, no, distance is the actual path or total path traveled by the object. Okay, and displacement is shortest path traveled by the object. Okay, so when I talk about displacement, final position minus initial position, no. Suppose a person is traveling from Hyderabad to Vizag. Okay, Vizag. Some approximate kilometers will keep, like 500 kilometers. Okay, so the distance traveled is 500. Again he is traveling from Vizag to Hyderabad. So total distance is 1000. But what about the displacement? Zero, because we are in the same position. Right now the final position and initial positions are same. So displacement is 0, but the distance are not equals to 0, right now. So total path covered by the moving object is distance. Shortest straight line path from the initial point to final point is displacement. Okay, so the types, scalar it is, distance is a scalar and displacement is a vector. What is scalar? It has only magnitude. Vector, both magnitude as well as the direction. Okay, so values always positive or 0. If a person traveling from Vizag to Hyderabad, okay, or Hyderabad to Vizag, we will say like he is traveling minus 20 kilometer or minus 500 kilometer. No, right? He is traveling some x kilometer or y kilometer, we will say it will be in positive. Or if he is not traveling, we will say it is 0. We won't say it is in negative, no. So distance cannot be in negative, it's always positive or 0, but the displacement can be negative, can be positive as well as 0. Okay, and depends upon the actual path taken, depends only on the initial and final position. Okay, when we talk about the symbol like D and S, okay, so in questions the symbols may be changed or may not be changed. Okay, so depends upon the question, we should take either it is a distance or displacement. Okay, and here if you see, whenever arrow mark is given, no, it's a vector quantity, so it is displacement. Suppose like S is given, it is distance. When S with the arrow mark is given, it is displacement. Okay, the main difference between them. Okay, an example, a car travels 10 km around a circular path. So if I talk about a circle, this is the circle, no, this is my circle. Point A is the initial point. I am traveling one circular loop, so distance will be 2 pi r, no, circumference of the circle. What about the displacement? 0. Starting and ending same, right? Now suppose if I take point B here, object is traveling from point A to point B, distance is 2 pi r by 2, which is nothing but pi r, half of the circumference of the circle, no? Yes. What about the displacement? It's not 0 and it is shortest distance, no, r plus r, which is nothing but 2r is the displacement, right? Now next is average speed and average velocity. So what about speed? Speed is nothing but distance by time. What about average speed? Total distance by total time. Okay, velocity is displacement by time. Okay, speed is distance by time, velocity is displacement by time. So average velocity is total displacement by total time, which is nothing but S by delta t, will say, or delta V by delta t. Okay, so once we will complete this, we will do the problems on this. Okay, so instantaneous, what is the meaning of instantaneous? At that moment we will say, like if you are traveling from one point to another point, okay, point A to point B, in the middle of that point, no, person is asking what is the speed, you will say some x kilometer, for example 70 kilometer per hour you are going, so which is nothing but instantaneous speed. But average speed may not be equal. Yes, no, it can be equal or it cannot be equal, but instantaneous in the sense at that particular moment what is the speed. Okay, so instantaneous velocity or instantaneous speed. Okay, magnitude of instantaneous velocity at any instant is called instantaneous speed. In the first example we have seen, no, velocity is equals to some I cap plus j cap plus k cap given. So if we take the magnitude of that, we will get the speed, no, velocity given, if we take the magnitude, I will get the speed. Here like the formula is ds by dt, differentiation. Okay, suppose example x is equals to 3t square plus 2t is the position equation. Okay, x is nothing but position, right, or s is nothing but position. Okay, this is position equation, and they are asking what is the velocity at time t is equals to 2 seconds. Okay, at time t is equals to 2 seconds. Keep in mind, whenever position is given and they are asking velocity, differentiation. Okay, position, velocity, acceleration, position to velocity, differentiation, velocity to acceleration, again differentiation only. Okay, double differentiation, position to acceleration, double differentiation. Okay, okay, done. So now what I should do to get the velocity? Differentiation. So differentiation of 3t square will be 60. Okay, like x is x power n, no, can be written as n into x power n minus 1. This is the differentiation of the differentiation formula for the thing. Okay, so here plus 2. Okay, they are asking at time t is equals to 2 seconds, right? Substitute the value, 6 into 2 plus 2, which is nothing but 14 meter per second. Done. Any doubts here? So one more type of question also can be asked. What is the velocity from time t is equals to 0 to time t is equals to 2? In this case, we should not do differentiation. What I should do is substitute the values here of the t values in the position. Okay, what I will get? For 0, everything 0. For 2, what is the answer? I will write here x 0 0, x2 will be equals to 2 square 4, 4 3s are 12, this one again 4, 16, no? 16. Okay, now velocity is nothing but change in displacement by time, no? Change in displacement by time, which is nothing but 16 minus 0 by 2 minus 0, which is equals to 8 meter per second. Okay, whenever I am getting from this time to this time, like this I need to do. Otherwise, if they are asking velocity at that moment, what I should do? Differentiation I need to do. Okay, differentiation. Any doubt in this? Next is acceleration. So first we have seen position, next we have seen displacement, next is velocity, final thing is acceleration. So displacement is nothing but change in position, velocity is nothing but displacement by time. What is acceleration? Rate of change of velocity with respect to time. So velocity by time, no? So displacement unit is meter. What about velocity? Meter per second, displacement by time. What about acceleration? Velocity by time, no? So velocity is meter per second. What about time? Again second, which is nothing but meter per second square. Okay? So define as the ratio of change in velocity to the time interval. So here final velocity minus initial velocity by delta t, change in time. Okay? So instantaneous acceleration again. Okay, instantaneous acceleration. So if velocity is equation is given, okay, if I differentiate, I will get the acceleration. Okay, suppose in this case, no, in this case they are asking what is the acceleration also. Acceleration at time t is equals to 2 seconds. So first we have differentiation and we got velocity. Next again if we do differentiation, we will get acceleration. So differentiation of this case will be equals to 6 and there is no t, no, so no need to substitute any value. So acceleration is constant. So 6 meter per second square is the acceleration for the given question at that time. Okay. Okay. So note point, if motion is one dimensional, then all vector quantities can be treated like scalar. Okay, assuming one direction as the positive and other as a negative. All vector along positive direction are given positive sign and vector is in negative direction are given as negative sign. Simple thing, the graph is there, no? This is positive y axis positive, positive x axis positive, negative y axis negative, negative x axis negative. Okay, going right direction positive, left direction negative, upward positive, downward negative. Okay, so keep remember in this one. Okay, you can take the direction of the velocities. Okay, now we will go for the questions. The first question. Okay, the first question. If displacement of a particle is 0, the distance covered, option 1 must be 0. Wait a minute. Wait. Okay, done. Option 1 must be 0, option 2 may or may not be 0, cannot be 0, depends upon the particle. So first thing, like we have seen, displacement can be 0, but distance may be 0 or may not be 0, right? Depends upon how it has been travelled or not, we can say. Cannot be 0. or depends upon the particle. So may or may not be 0. Option 2 is the answer. Right now? So next question. Yeah. A particle cover half of the circle of radius r. So there is a circle which is having a radius r. Then displacement and distance of a particle r. Okay. They said that half of the circle, no? Half of the circle in the sense from this point to this point it has been travelled. So this is total circumference is nothing but 2 pi r, no? 2 pi r. So half means divide by 2, which is nothing but pi r. Okay. This is my distance. What about the displacement? R plus r, 2r. Right now? So which one is the answer? Second option. Right now? They have asked the displacement and distance. This displacement is 2r, distance is pi r. Option 2 is the answer. Right now? So next one. A person starts walking. Wait a minute, I will zoom it out. Okay. A person starts walking and comes back to its initial position after 2 hours. Then which of the following quantity is 0? Path length, average speed, displacement, time. Path length can't be 0, no, it will be there. Average speed, speed is nothing but distance by time. Distance also can't be 0. Displacement, obviously. Time, obviously time will be there, no? Yes, option 3 is the answer. Done. So fourth one. If a magnitude of average speed and average velocity over a time interval are same, then give the answer for this question, we will see. Tell me. If magnitude of average speed and average velocity over a time interval are same, they are saying that velocity and speed are same, no? So particle must move in the zero acceleration, particle must move with non-zero acceleration, particle must be at rest, particle must move in the straight line without turning back. So when I talk about speed, no, distance means like it's going in the straight direction or any direction it can be, but it is not negative, na? It is not negative. So velocity can be negative, can be positive, 0 also. What they told? Over a time interval are same, which means particle must move in a straight line without turning back. Okay. So next one, this important thing. Yeah. So body covers 1/3 distance with velocity v1, second 1/3 distance with velocity v2, and last 1/3 with v3. So what they are saying is there is a distance of d. Okay. So first 1/3 distance, no, d by 3, no? D by 3 with v1, again d by 3 with v2, again d by 3 with v3. If I add d by 3, d by 3, d by 3, I will get d. The total distance is d. Okay. What they are asking? Average velocity. Average velocity means total displacement by time, no? So what I should do? I need to find the velocity of v1, time t1, how much it has been taken here. So t1 will be equals to, so v will be equals to d by t, where t1 will be equals to d1 by v1. What is d1? D by 3. Can I write like this? D by 3 by v1. Then no? Again T2 also can be written as d by 3 by v2. T3 can be written as d by 3 by v3. Any doubt here? Fine. Now velocity. Average velocity, V average will be equals to total distance, no, d1 plus d2 plus d3 by t1 plus t2 plus t3. What is d1? d3, d2 d3, sorry, d by 3, d by 3, d by 3, no? I will write d by 3 plus d by 3 plus d by 3 by t1 is, yes, d by 3 by v1 plus d by 3 by v2 plus d by 3 by v3, right now? So d by 3 common I can take from numerator and denominator. So what will happen? 1 by 1 will come, 3 will come, no? d by 3, d by 3, d by 3 will, if I take commonly outside, 1 plus 1 plus 1, 3, right now? Yeah. So 3 by 1 by v1 plus 1 by v2 plus 1 by v3. I will write here now. So 1 by v1, 1 by v2. Can I take LCM now? What will happen? 3 by v2 plus v1 by v1 v2 plus 1 by v3. Correct, no? Cross multiplied. v2 plus v1 by v1 v2 plus 1 by v3. This is v average. So again I can take LCM. So cross multiply. 3 by v3 of v2 plus v1, right now, plus v1 v2 by v1 v2 v3. Any doubt here? I have cross multiplied and I have taken. Now should be equals to v2 v3, v1 v3 and v1 v2 are there. Now 3 by, can I take this one to the numerator? 3 v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1, right? So this is my average velocity for the given question. Okay, so option 3 v1 v2 v3 by v1 plus, v1 v2 plus v2 v3 plus v3 v1. Option 2. So now one more question I will give. There is a distance travelled is d. Okay, so 1/3 of distance. Okay, 1/3 of distance is v1. 2/3 of a distance is v2. Find v average. This is the homework question. Okay, take this question. 1/3 of a distance is v1. 2/3 of a distance is v2. I need to find the v average now. Okay. So with this we will end this class and we will continue with the next part of the session in the next class. Okay, fine.